Students, next question here we are discussing which of the following pairs is not correctly matched. So, is given 4 pairs. In option A is given a pair line charge Gauss law. In option B is given a pair power flow Poynting vector. In option C is given displacement current Ampere's law. In option D is given magnetic field Biot-Savart's law. So, out of these 4 pairs, one pair is not correct. Which pair is not correct? That means which is not related, which is not matched. See here. First I am considering option A. In option A is given 2 terms. One is line charge rho L and is given Gauss law. Yes. Here according to Gauss law, the total electric flux through a closed surface is equals to the total charge enclosed by that surface. So, by using this Gauss law, we can determine the total charge and field components due to charge distributions. Remember, very important point here, there are 2 basic laws in electrostatics. One is Coulomb's law, second one is Gauss law. What is the difference between these 2 laws means? By using Coulomb's law we can determine the field components due to point charge, whereas by using Gauss law also we can determine the field components due to distribution of charges. So, if charge is distributed along a line, then we are considering line charge density. If charge is distributed on a sheet, then we are considering surface charge density. If a charge is distributed in a volume, then we are considering volume charge density. So, there is a relation in Gauss law and line charge. What is the relation means? By using Gauss law we can determine the field components due to line charge. So, it is a matched pair, right. Option B is here power flow Poynting vector. Yes. By using Poynting vector, vector P, Poynting vector, power density E cross H. What is E here? Electric field intensity. H is magnetic field intensity. What is the E units? Volts per meter. H units ampere per meter. Volts per meter into ampere per meter means watts per meter square. So, here power flow, yes, by using this Poynting vector we can determine power, we can calculate power, hence this is also a matched pair, Poynting vector, power density. Displacement, option C I am telling, displacement current Ampere's law, yes, it is not pair, it is not matched. Why it is not matched? Because Ampere's law. What is Ampere's law? The line integral of magnetic field intensity. Around a closed path. Is always equals to the net outward current. From this I equal to I am writing surface integral of J dot ds. But this J is a conduction current density which is in conducting medium, which exhibits in conducting medium, but here is given displacement current. Displacement current can be determined from displacement current density, that is ZD, where it will be considered means if the medium is a dielectric medium. So, the given J conduction current density is not same as displacement current density, hence curl H equal to J, that is from Ampere circuit law, but that is not JD. JD means displacement current density, hence this is not a pair, this is not matched. Option C is the answer. And last one, what is the D? Magnetic field Biot-Savart's law. Yes, by using Biot-Savart's law, we can determine magnetic field either B or H. So, this is also matched pair. So, out of these 4 pairs, option C is not pair, not matched, because there we consider conduction current only, not displacement current. Option C is the correct answer here. Friends, now we are discussing one more question. The question is, for a moving charge q in the presence of both electric and magnetic fields, the total force on the charge is given by. See here we are considering a charge q. This is a point charge q. So when the charge is moving, in electric field, now I am calculating the force due to electric field. The force due to electric field is equal to, I am writing Fe, electric force. Fe is equals to QE, newtons. This is equation 1. Similarly, the force due to magnetic field now we require. The force due to magnetic field, FB, FM, that equal to, I am writing here very important formula, that is Q into V cross B. What is V here? Velocity of the charged particle. B is magnetic flux density. So when a charge is moving in a magnetic field B with a velocity V, the force exerted is Q into V cross B. Now here the charge is moving in both fields, means electric field as well as magnetic fields. Then the resultant force, F equals to, F is equals to Fe plus Fm, electric force as well as magnetic force. What is electric force is here? That is QE newtons, and magnetic force is Q into V cross B newtons. So finally the resultant force F equal to, I am taking Q common in two equations, Q into E plus V cross B. E plus V cross B is the answer. This is the answer. Force F equals to Q into E plus V cross B newtons when charge is moving in both electric field as well as magnetic field. So here the correct answer is Q into E plus V cross B, means option D is the correct answer. Students, now we are discussing one more question. Which of the following equations represents Gauss law adapted to a homogeneous isotropic medium? So there are 5 options are given. Closed loop surface integral of d dot ds equals to volume integral of rho v dv. Curl h equal to d. Option 3, curl j plus rho equal to 0. Option 4, divergence of E equal to rho by epsilon. Option 5, del square phi equal to 0. All these are valid equations. What is this equation? Means Gauss law in integral form. What is this equation? Gauss law in integral form. That is valid equation. And curl h equal to d, that is not correct. Actual equation is curl h equal to j. So this equation is wrong. And third equation is also wrong. Divergence of j is equals to minus dou rho v by dou t. There is no curl operation, this one. And option 4, it is correct. Divergence of E equal to rho by epsilon, that is rho v by epsilon, no problem. And option 5 is also correct. If phi is a potential, then del square phi equal to 0. So here option 1, option 4, option 5 correct. But again is given one more condition. These 3 in that also which are satisfied in homogeneous isotropic medium. So, it is the medium where the medium parameters are constants. So, we are discussing in this question all formulas are related to except to 2, that means except invalid options. All valid options are related to electrostatic. In electrostatic the medium parameter is permittivity. So, in a homogeneous medium permittivity is a constant. Permittivity, that is epsilon, is a constant. So, equation 1, equation 4 correct, because this equation is correct in this medium. What is that one means? Del square pi equals to rho v by epsilon. Del square pi equals to del square v equals to minus rho v by epsilon, that is the correct equation, but here is given 0 means volume charge density equal to 0, that is not valid in this medium. So, option 1, option 4 both are correct, both are valid in homogeneous isotropic medium. Next we are discussing one more question. What is the magnetic flux density at the center of a current carrying loop when radius of loop is 2 centimeter, current is 1 milliampere and loop is placed in air? This is the question. So, we know that magnetic field intensity due to current carrying loop is what? I by 2R, ampere per meter. This is the formula, but is asking magnetic flux density, that is B. B equals to, I am writing here mu naught H, B equal to mu naught H, that equal to mu naught into H equal to, I am writing I by 2R. So, from this I am writing mu naught equals to 4 pi into 10 power minus 7, and what is the current? That is 1 milliampere, 1 into 10 power minus 3 divided by 2, radius is 2 centimeter, that is 10 power minus 2 meter. 2 2 is 4, I am cancelling 4, that equals to pi into 10 power minus 10 into 10 power plus 2. Pi value I am writing 3.14 into 10 power minus 8 Weber per meter square or Tesla. So, what is the answer here? 3.14 into 10 power minus 8 Tesla is the correct answer. Option B is the answer.